Why we forget. Well, what is forgetting? Well, forgetting is quite simply defined as the inability to retrieve information. It's a natural process, and it occurs when information is unable to be retrieved from memory, and the inability increases with time since encoding increases. It increases with time since encoding increases. So the longer it's been since you've encoded the thing you're trying to remember, the more memory is increased. Ebbinghaus was really the first guy who documented learning. He documented his famous forgetting curve, and he showed that it follows a very typical pattern where a lot of information is forgotten very quickly after you study, but then the rate of loss goes slower as the length of time increases. Another reason for forgetting, of course, is that it can be due to a lack of consolidation. In other words, the actual creation of memories. Consolidation is, we think of consolidation as a neural process by which the memories are strengthened and more permanently stored in the brain. We don't know exactly how consolidation works, but we know that our brain must do something to permanently store memories in the brain. One thing that does seem to help consolidation is sleep. Sleeping does seem to help quite a bit. This is a picture of Ebbinghaus's classic forgetting curve. Along the x-axis, we have the number of days between study and test. So each one of these dots on this line represents a different time that you were tested on something that you studied there at time 0. And then along the y-axis, we have the mean proportion of the nonsense syllables or the list of words that you recalled. Notice if I test you right away, you're able to remember anywhere from almost 100% to 60% of the list of words or nonsense syllables that I gave you. But look by day 5, it looks like we're down to like 20%, and it sort of just stays there where you can kind of only remember 20% of what you learned. And this is Ebbinghaus's classic forgetting curve. Let's talk a little bit about encoding effects, encoding information into memory. One of the most influential theories on encoding has been Craik and Lockhart's levels of processing. Craik and Tulving's levels of processing. And basically what levels of processing means, it's an effect on memory that shows better memory for information that's encoded with deep processing rather than with shallow processing. Now, what is the difference between deep and shallow processing? Well, shallow processing is where you're just encoding information based on its surface features, just kind of looking at it and not really thinking about anything much other than the way it looks. Deep processing is where you encode information according to the meanings that you're able to comprehend and extract from whatever it is you're trying to learn. Now, the classic example that I always give my students is studying by simply reading and highlighting the information in your textbook versus studying by reading your textbook, outlining the chapters, looking up words you don't understand, and then rewriting the chapters in your own, or I should say summarizing the chapters in your own words. Notice the two big differences there between just sitting there passively reading and highlighting versus actively using the information. That is the difference between deep processing and shallow processing. And another term for deep processing is elaborative encoding. So that's what the levels of processing is. It's based on elaborative encoding. So the more elaborate you encode, whether it's deep or shallow, the better your long-term memory is going to be. If you encode information according to its meaning, that's going to help your long-term memory. So, to use this as an example for studying, you're going to do much better on a test if you study by really using the information. And there are lots of ways to use information. Some of the simple ones are to write summaries of each chapter in your own words, to actually outline each chapter and look up the words and that you don't know the meanings of. Look them up in a dictionary. Answer the questions and do the exercises throughout the chapter and in the back of each chapter. Every good textbook has lots of questions and exercises at the end of each chapter. All of these tools are ways to get you to use the information, understand its meaning, and therefore encode it deeply. And that's what I mean by using the information. It's essentially doing deep processing using this elaborative encoding technique that Craik and Tulving worked out some time ago. If you look at this particular slide, each subject was given one of three tasks or one of three ways of encoding words. One was to encode it as to whether or not it was in capital letters. The other was to look and see if the word rhymes with another word. And then the third was to actually categorize that word into different types of category, into what sort of a category that word represented. So with the example, the word shark, right, is the word in capital letters? Yes. Does the word rhyme with park? Yeah. Is the word a type of fish? It is. Notice that if we look at if we go and give people a whole bunch of these words, and you'll notice that those that encoded the words according to categories, that actually went and used were given different category cues to encode the words, to understand what each one meant, almost had a perfect recall of all of the words, versus the ones that just looked in whether or not the word was in capital letters or in lowercase font. They were barely able to recall even 20% of the words. So the take-home message here in this very important study was that deeply encoding the meaning of a word, in this case, figuring out what category of meaning was assigned to each word, really helps a lot in long-term memory. Spacing effects. Melton in 1970, one of the things that Melton showed was that breaking up your studying for 1 hour every day for the week before an exam, for a grand total of 7 hours, results in better memory for the material than studying for 7 hours a day before the exam. And it turns out that multiple studying episodes provides more varied retrieval cues. So in other words, one thing you don't want to do is just sit there and study for a grand total of 7 hours right before the exam. The reason being is that you're not giving yourself enough variety to help you later on, to help you remember things out of your long-term memory. If you break the spacing up across several days, you will be able to utilize different retrieval cues that you've experienced across those 7 days to help you and aid you in recalling that information later. One of the things that about the way we process information is that we process it serially. In other words, we take one at a time. We take information one at a time, whether you're reading or listening to a lecture or going through an art studio, whatever it is. We do things serially, one at a time, one after the other. And it matters at what position you experience certain things that you're serially processing, whether you see them first in the process or whether you see them last or later on. The first information that's encoded and the last information that's encoded tend to be remembered better than all the stuff in the middle. The primacy effect is when the first information that's encoded shows a memory advantage. So, let's say you go to let's say you go to a really long meeting. You're in a meeting for like 2 hours, and you come out of that meeting and somebody asks you, well, what happened? And you say, well, you're able to recall like the stuff that was talked about the first 15 minutes of the meeting, but then after that, your memory just fails because you zoned out. That's a primacy effect. You're able to remember what happened up front. When the information that was last encoded is better able to be recalled, that is called a recency effect. And that's really more related to, your short-term or working memory. So let's say you go to a basketball game and you're watching this basketball game, and like most basketball games, all the excitement is at the end. So you sit there and you watch the end and you watch this basketball game, and then when somebody asks you about the game, what you're able to remember the best is what happened at the end. What's most recent in your mind, what was most recently experienced, and that's what the recency effect is all about. This primacy and recency effect together are known as the serial position curve, meaning that we're able to remember stuff that is at the beginning of a series of stuff we have to learn, and we're able to remember stuff at the end of a series of stuff we have to learn, but we're not so good at remembering the middle. It's kind of like muddled out, and you end up with this kind of like U-shaped curve here that you see in this particular graph. Along the x-axis, we have a list position. Let's say it's a list of words from 15 words, and then we have on the y-axis we have the amount of recall, the proportion of words that were correctly recalled. And you'll see that especially with the no delay, the yellow line on the no delay, notice that these subjects were able to remember a lot of the first 2 words very well, and really the last 2 or 3 words very well. The ones in the middle, not so much. They weren't able to remember those as well as the ones at the end and at the beginning. And this is the serial position curve, the famous serial position curve. The testing effect. The testing effect is reviewing information by means of an intervening test. I'm sorry. Let me say it again. The testing effect occurs when you review information by means of an intervening test. And when you do that, when you have a little intervening test, that helps you in later retrieval, right? So you read something and later on you quiz yourself. If you do that, that's going to help you later on in retrieving that information, like, for example, studying for the test. Testing yourself or practicing retrieval is really the absolute best way to study material. So, reading a little bit, testing yourself, using elaborative rehearsal to understand it, that is a guaranteed great way to study. With regard to encoding retrieval interactions, one of the very important concepts that's introduced in your text is the encoding specificity principle. And what this is basically matching the circumstances of encoding and retrieval. You want to match the circumstances of encoding and retrieval to aid your memory. Simple example are some environmental context effects. Environmental context is making sure that the study conditions and the test conditions are the same. For example, a lot of folks like to listen to music while they're studying. Well, that may not be a good idea. The reason that's not a good idea is because you're probably not going to be allowed to listen to music while you're taking the test. So there's a mismatch between the encoding of the information, or I should say there's a mismatch between the environmental context of encoding and the environmental context of testing. Because in one you have music, and in the other one you don't have music. That is going to result typically in in reduced retrieval of information out of your long-term memory. Besides environment, besides things like music and other things about the environment, another one are mood-dependent effects. Memory performance is higher when your mood in the study and the test conditions are the same. So if you're like super duper depressed while you're studying and then later on you get super duper happy, that's probably going to affect your performance, believe it or not. All of this has been put together into this concept of transfer appropriate processing, and this is basically an effect of in memory that shows that matches in processing between encoding and retrieval improve memory. So if you are really working, or if you're really concerned about improving your memory retrieval at some future task, well, during study, you want to make sure that you are keeping the conditions, your mood, the environment, as much as equal to the future mood and environment that you're going to have when you're being tested. In that way, you can make sure that you maximize the long-term memory retrieval. So figure 6.8 in your book is a classic example. They had two different study conditions. They had subjects that studied underwater versus subjects that studied above water. So they had some people in scuba gear studying, I think they were learning nonsense syllables, and subjects above water. And then what they did was they took each one of those two separate groups that were studying underwater and studying above water and split them for a test condition. Half of the ones that studied underwater did their recall test underwater, and half of them that studied underwater had to do their recall test above water. And the opposite was true for the ones that studied above water. Half of them got to do their recall test above water, and half of them had to do their recall test underwater. So there was an environmental mismatch, an environmental match for each one in each one of these conditions. So the environmental mismatch is if, for example, if you studied underwater, but you did your recall test above water. And as you can guess, if you studied underwater, then your recall was much better if you were tested underwater. And similarly, if you studied above water, your recall was much better if you were tested above water in the same type of environment that you did your studying in. In another study looking at the testing mood-dependent memory effects, we had, again, people studying a list of items, but this time they were put either into a happy mood or a sad mood using music. Music is a great way to manipulate mood in experiments. And so they were put into a happy mood or a sad mood, and then asked to study a list of items. And then each one of the groups of the happy group and the sad group was then broken up into two subgroups. Just like in the previous study, some of them were able to do their recall test while in the same mood that they were studied in, or they got switched to the other mood. So you had a mood match or a mood mismatch. And sure enough, if you studied your list of items when you were in a happy mood, and then you were tested when in a happy mood with happy music, or if you were placed in a happy mood with happy music, you would do better than if you were if you were put into a happy mood and then studied, and then put into a sad mood and then tested. Encoding retrieval interactions can get pretty complicated. This is a study from Meyer and Graf 2000 that looked at two different types of prospective memory tasks. One type of prospective memory tasks, the two general types of prospective memory tasks, a meaning-based prospective memory task versus a visual form prospective memory task. So for example, I would ask you to look at a series of words flashing on a screen, and I would ask you to push the button if the word represented an animal. So you'd be looking at all these words, and if you saw the word cat, you'd push the button. If you saw the word elephant, you'd push the button. That's a meaning-based prospective memory task. You have to sort of process the meaning of the word in order to respond properly. The other type of prospective memory task was a visual form prospective memory task, and this was one where basically I would ask you, press the button if you see a word with 3 A's in it or 2 C's. In other words, I'm just asking you to respond to just visually what the word looks like. Notice these are two completely different sorts of tasks. One involves them processing the semantic meaning of the words. The other one is really just looking at the visual form of the word. Well, it turns out that if you are asked to do this task, and then I give you another task to do, an ongoing task, one that is meaning based versus one that is visual form based. Well, if you're doing the meaning based task, like for example, I'm asking you to respond to animals, and then I give you another meaning based task, say, if you see a picture, tell me if it's a natural item or a fabricated item. That would be a meaning-based task versus if you see this picture, tell me how many enclosed spaces it has, which is just really, again, visually how it looks. If I give you this ongoing task after you've already had either the meaning-based task or the visual form task, you're going to do better on the task that matches what you've had previous experience with. So if I gave you the meaning-based task of responding to animals, and then I gave you another ongoing meaning-based task to ask you whether or not something is natural or fabricated, you're actually going to do a lot better in recall of those items, or the performance of responding to those different tasks versus if I were to give you a meaning-based task and then give you a visual form ongoing task. So the results show that transfer appropriate processing does occur for these like future memory tasks, these things that you have to keep in mind to use, these rules that you have to keep in mind to use for the future. Mnemonics. Mnemonics are memory techniques that have been used by humans really for thousands and thousands of years. Mnemonics are tools that that we use to help us to remember information and to store information in long-term memory. There's a lot of different mnemonic techniques that are out there. One of the more well-known ones is the method of loci, or loci, L-O-C-I. The method of loci is a mnemonic technique where you basically create images in well-known locations involving items that you need to remember. So for example, if let's say you have to remember to go pick up your prescription, and from the drugstore and get your dry cleaning and pick up some beer. You might have, you would visualize in your mind your living room with a bottle of pills on the table, a cold beer sitting next to the pills, and the dry cleaning draped on the couch next to the table. You would have that visual image in your head of the dry cleaning, the beer, and the pills, and that would help you to remember those three things that you need to keep in mind. So here's an example, mnemonics, which is easier to remember. So read the following sentences, close your eyes, and imagine them as you read. Then after that, count backwards by threes from 100 and then try to recall the sentences. So first, read the following sentence, close your eyes, and imagine them as you read. And then do a count backwards by threes from 100. That's your distraction task. And then try to recall the sentences. So here's the sentences. So if you did this, how many of the sentences could you remember? Try it again with the same procedure, but use these sentences. Oops. People usually report that the second set of sentences, namely this one, is a lot easier to remember. And why is it easier to remember? Because it's they are much because of the bizarreness. Things that are unusual stand out. They attract more attention, and therefore they are more easily recalled. This bizarreness effect is very well known. The method of loci can be used easier, right? When things are bizarre, right? If you have a familiar route that you walk or drive every day, you can use that as sort of what's called a memory palace. That is this general route along which you can place different objects to aid you in future recall. Autobiographical memories are memories of your day-to-day life. Some people claim to be able to report what occurred on any given date during their lifetime. The cause of that sort of superior memory, like what's described here by Parker in the case of AJ, is really unknown. This person probably didn't use mnemonics. However, there have been some studies that have looked at some of these types of people with these incredible autobiographical memories. And one of the things that has been anecdotally noted is that they seem to have slightly unusual hippocampal development. So their hippocampi, the structures in their brain that are related to the formation of memories, seem to be a little bit bigger than people that do not have this sort of a superior ability to remember every little detail of their lives.